Now see this example, there are two masses M1 and M2, both are placed on the surface which is actually frictionless, there is no friction. M1 is equal to 50 kg, M2 is equal to 150 kg, and force F is applied this side. Both the masses are tied by a light string, and with the help of the force F they are pulled to this side, and the system moves with the acceleration A is equal to 5 meter per second square. Now we have to get the value of F and the tension in the string. So now see, when force F is applied to this side, so we can redraw the diagram. Suppose it is here 50 kg tied by a string, here is 150 kg, this you are applying force F to this side. So this tension is acting to this side and this side. This is pulling to this side and this is pulling to this side. Whole system is moving, A is equal to 5 meter per second square to this side. First we take body first one. If you take this body, you will be saying there is 50 kg force, F is acting to this side, T is acting to this side, A is acting to this side. We can write net force F minus T is equal to 50 into A, that is means F minus T is equal to 250 because A is equal to 5. Similarly, if you take this body, second one, there is only one force, that is tension to this side. So we can write T is equal to 150 into 5, that is T is equal to 750 Newton. So this is the tension in the string. So we have calculated tension. First we had to find out tension. Now we have to calculate F also. So we can calculate F, put the value of T in this equation. So you will be getting here F minus 750 is equal to 250, that will be here F is equal to 1000 Newton. So this is the force F.